All right, next topic up is work. And in this case, we're not talking about a job. We're talking about work in physics, a little bit different than going to work somewhere else, getting paid for it. So mainly what we're looking at here is just real short and simple today. What is work? How do I calculate it? And that's effectively the only vocabulary we have. All right. So I got an image here of someone with a box picking it up, and this is kind of what we're thinking about when we're talking about work. So effectively what work is transferring energy through a force over a distance. Mathematically, what this looks like is simply that it's a force times a distance. So you got to push something and you got to move it. That's going to be what our work is going to be all about. Or it can also be defined as the change in kinetic energy. So if there's more kinetic energy from beginning to end, then there's positive work. There could also be negative work. There could also be no work. So we can also analyze a situation through the change in kinetic energy to find out, is there a change in the net or total amount of work that's been put into something? And like energy, it's also being measured in joules. So a couple of things to think about as we're doing this. Work can be done on an object or it can be done by an object. So you may have situations where it says blah, 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 what is the work done on the box if something's being pushed? Or I can say, what is the work done by the person pushing the box? So in both of those cases, we're looking at what is the push, how far is it going, to be able to calculate that. And again, if you see network, again, that's not like network, but net work. What we're talking about here is the change, how much from beginning to end. And so if there is a change in kinetic energy, then there would be a network. If there's no change in kinetic energy, then the network would be zero. Right? Things worded as doing work on an object. And so for my example, if I'm pushing something around, then I am doing work on that object because I'm pushing it and it's moving. If I push it and it doesn't move, then I'm not doing work. So that the distance has to be something. Just pushing is not good enough. I need to move it. So something may be worded about, how much total work is being done on an object. But then again, so you're thinking of when an object is moving, if I'm pushing it along the floor, then I'm doing work on the box, but there's also friction doing work in the opposite direction. And so again, if the network can be zero, if there's not a change in kinetic energy. So envision a box at rest, it's just sitting there. You start pushing it for a while and then you stop pushing it. Even though you pushed it, even though it moved, overall, there's no network being done on it. I got a little bit misspelled word there. That should be on it. The kinetic energy didn't change, right? So the kinetic energy at the very beginning was basically zero because it wasn't moving. The kinetic energy at the end was also zero because it wasn't moving. And so there was not a change in the kinetic energy. Now, how much work did I do on the box? I could calculate the amount of work that I did on the box. That would be how hard I pushed and how far it went. But the net force on the box, the net work on the box would end up being zero because there's no change in the kinetic energy with that. So some example problems of how to look at these types of things. How much work is being done by a weightlifter? It shows below, but this is not really a weightlifter, who applies 500 newtons of force lifting a mass 2.5 meters. Go to your reference sheet, work is force times distance, plug in your numbers. The force is 500 newtons, the mass is the distance is 2.5 meters, and we just multiply those together, 500 times 2.5, and the amount of work is 1,250 joules. If this was my weightlifter and they were applying 1,000 newtons but didn't move the mass, how much work is being done? Again, same formula. The force is 1,000, but the distance is zero because it didn't go anywhere. So even though they're pushing and pushing and pushing, there's no work being done on the object if it is not moving. So the answer in this case would be 0 joules. So we got to get some kind of movement in order for work to be done on an object. What about this example? It says if a worker lifts a box from the floor, moves it 5 meters over, and then places it on a shelf 1 meter for the floor, how much net work was done on the box? And it seems like this will be really, really complicated, but again, we can think about how much net work was done on the box. What we're looking for there is the change in kinetic energy. Well, at the beginning of the situation, the box wasn't moving, and at the end, the box wasn't moving. If you don't have movement, you don't have any kinetic energy. So basically, there was no kinetic energy at the beginning of the situation. There's no kinetic energy at the end of the situation. So there was no change in kinetic energy. It went from 0 to 0. And so there was, since there was no change in kinetic energy, we would just be able to say that there was no work done. There was no net work done on the box. Now, there's portions of this where you could figure out how much work did I or the worker do on the box. So we could do the 5 meters and we'd need to get the weight of this box. So we can remember kilograms of mass. To get a weight, we need to do gravity, which will be 9.8. So if we had 9.8 newtons times 5, there was work done by the person on the box moving it side to side. There was work done by the person moving it up, but the net work done on the box is actually going to be 0 because, again, as I was pushing it, friction was pushing it backwards. And as I'm lifting it, gravity is pushing it downwards. So there's some canceling out of going on there. So if there's not a change in kinetic energy, then there's no net work done on that.